Hello everyone, it is Quintickle here with another video. Today, in the previous video actually, I've talked about what a second degree equation is and how to solve it using the quadratic formula. So today we're going to go ahead and try to implement this in code blocks, C++, to see if we can create an equation solver. So we're first going to declare our coefficients, int a, b, c, and then read them. A, sin, a, b, and c. Good. Now we're going to say to the user, is this your equation? Y or no? We're going to do end line, and then we're going to see out his equation. Now I've already got some stuff prepared up here, I'm sure you've noticed. This is the symbol in the ASCII table for the squared symbol. Okay, so we're going to do cout ax squared plus bx c is equal to 0. End line, let's test if that works. Good, add a space right there, compile, everything works fine. 1 to 4, nope, almost fine, there we go. 1 to 4, and x squared plus 2x plus 4, yes, that's our equation, perfect. Now I'm going to do char option of 200, actually no, just an option, and then I'm going to read it. Good, and I'm going to say if opt is equal to y or opt is equal to y, we're going to solve it, else cout try again. End line. Good, perfect. Now now that we know the equation, we're going to declare our roots, root 1 and root 2, root. Good. Now, that's simple. We're going to do the quadratic formula. Root 1 equals everything in a parenthesis, more parenthesis, minus 1 multiplied by b, so that'll be minus b, plus the square root of b squared minus 4ac all over 2a. Now I'm going to copy that. I'm going to say root 2, and it is a minus here. Good. So we're going to see out our roots and see if this works. Root 2. Good. Let's see. 1, 4, 4. Yes, it's my equation. The roots are minus 2 and minus 2. That is great. It's actually great. So, right now we want to see out the solution. So the solution to this, the formula says that the solution to this is x minus root 1, okay, and x minus root 2. So you might think that's all we have to do, right? Cout x minus, and then we're going to do root 1, close the parenthesis, open parenthesis, x minus, root 2, close the parentheses, and say it's equal to 0. Good. Do an end line. Okay, you're going to see that while it is technically what you need, see, you get x minus minus 2 all over x minus minus 2, it's equal to 0. So we're going to do something sneaky over here. So we're going to say if root 1 smaller than 0, so we're going to do cout. We're going to do what's called concatenating strings. So we're going, this part here never changes, so we can simply output it, dot and comma, and we're going to say if root 1 is smaller than 0, then we're going to have to say cout plus root 1 dot and comma else cout minus root minus root 1. Then we do cout parentheses minus x. Good. That is this part. Good. And now we do the same thing again. I'm going to just copy and paste it. And if root 2, then cout the root 2, then cout the root 2. Perfect. So we're going to say 1, 4, 4. This is in my equation. Yes. This is x plus... Oh my god. Yeah, I forgot something. In this case, I just have to cout the root. And in the other case, I have to cout the root multiplied by minus 1. And you might be wondering, but why are you doing all this? Well, technically, why I'm doing this is basically if we're placing the root... Wait, this is not supposed to... Yes, actually this is... Because doing this, if it's smaller than 0, it means it has a minus. So we multiply it to get the modulo of it and get rid of the minus. And then we add the plus. Otherwise, we just cout it, and it already has the minus because it's smaller than 0. And we do the same thing for the other, and when we compile it, we get exactly what we need. 1, 4, 4. This is my equation. Yes. And I forgot a parenthesis. Cout, closed parenthesis. Let's see if this works. 1, 4, 4. Is this my equation? Yes. The answer is x plus 2. Yes. That's perfect. All well and good. And we're going to try again. Yes, and you can see we get this. Oh, I accidentally added two equals. But I want something better than this. I want to make it even better. So what we're going to do is if... I'm going to add everything here. A tab. I'll do that quickly. Good, perfect. And I'm going to open brackets here, close them here, and I'm going to say if root 1 is equal to root 2. Actually, no, it's different. Then I'm going to say else. Perfect, and I'm going to cout. I'm going to do this. And then I'm going to cout. Oh, I already couted it. It's up there. Perfect. Okay, so it's the root. Okay, perfect. And then I'm going to cout closed parentheses. And then squared. End line. Let's see how that goes. 1, 4, 4. Yes, it's my equation. It's x plus 2, everything squared. We're doing great. Is equal to 0. Good. 1, 4, 4. And this is my equation. Yes. And we got x plus 2 squared is equal to 0. Perfect. Now, what do we want to do next? Well, it's very annoying that when you type 144, you get this, which is annoying. So we're going to do something different. If we're going to have a cout here, if a different from 0, it'll see if it's different from 1, it'll cout it, and then it'll go all the way to squared, and this is where we stop again. Put a bracket, do cout, stop again, put a bracket, cout, if b different from 1, cout all the way there, put a bracket here, cout this, and if c is different than 0 in this case, because if we add 0 there's no need to show it. Okay, cout. Okay, perfect. Let's see if that works. X was not the... Oh, see. Okay, perfect. So if I do 1, 4, 4, you're going to see we get the actual equation. X squared plus 4x plus 4 is equal to 0, and if we type yes, we get our result. It's x plus 2, everything squared is equal to 0. Now, there are equations in which 10, let's say 10, 10, 10, yes, this is my equation. We do yes, and it crashes. I mean, it doesn't crash, but it gives off this very weird number. So what we're going to do is, the reason this is happening is because this square root here is getting negative. So we're going to get the roots, but before that, we're going to say if this square root gets negative, and we're going to put it all in between braces, and we're going to say is smaller than 0, then we're not going else. Only then do we do that. Good. Else see out the coefficients. I spelled it wrong. That's definitely spelled wrong. The variables are incorrect. The square root is negative. And this should prevent us from overflow protection. Now, I'm going to prove that to you. 10, 10, 10. Is this your equation? Yes, the variables are incorrect. The square root is negative. But if we give it something good, like, I don't know, 1, 4, 4. Is this your equation? Yes, it is. It gives us the result. And there's also, I haven't tried with negative coefficients yet. So I remember it was x, it was 1, -1, and 6. Oh, we forgot about -1. But we're going to do all of that. The square root. Okay, so the equation solver is pretty much complete at this point. I mean, there's not much else you can do to it other than maybe some more styling. But god damn it, I need a 10-minute video, so we're going to do it. So also, we're first going to add if and a different from -1 if a smaller than if a is smaller than 0, we're going to see out a small plus. We're going to see out a small negative sign here. Good, and let's see how that goes. -3, 5, 4, -3, minus x. Boy, that went wrong. So, if a is equal to -1, see out the little x. The little minus thingy. Minus. End line. Perfect. And we're going to try that right now. -3, 4, 4. Is this -3x? Yes, that works. And if we give it -1, 3, 3, it gets us. I had an end line, haven't I? My god. So, -3, 4, 4. And we get yes, I've already tested that. -1, 3, 3, it's -x, perfect. Now, I'm going to see -1, -2, -3. As you can see, it doesn't handle these cases very well. So what we're going to do is actually pretty simple. We're going to say if, right here actually. So x squared plus, and now this is where we make our move. We remove that and we say if b smaller than 0. We don't. If b is bigger than 0, only then do we see out the plus thingy. Don't put the end line, Matt. Good. And now let's see. -1, -1, -1. And it didn't work. Oh, actually it did. But it shouldn't have. And we're going to say if b is different than 1, then we're going to add if b different than -1, else see out a little minus sign. Right, let's see. -1, -1, -1. This is minus x squared minus x plus minus 1. Okay. We also need to fix c, which will take about a second or two. X plus. This plus needs to be removed. Okay, and then I'm going to add proper spacing and all of that. Good. So let's see. We're almost done with is this your correct equation. So we're counting x, and this is where we need to worry a second. If c is different from 0, we're going to see out c. And also, if c is smaller than 0, then we're going to see out c. Else, c out plus c. Good. Wait, I added the 0. I mean, I added the end line. Good. So let's see. Minus 1, minus 1, minus 1. And we get it perfectly. And now I'm going to add some padding, just to make everything look nicer. It'll take just a second. That was my mouse, if anyone is wondering. Okay, minus 1, minus 1, minus 1. And I put too much padding. There. Minus 1, minus 1, minus 1. And we get the correct equation, but we don't get a minus. We don't get space there. Why? X minus... Oh! I know the reason. Minus 1, minus 1, minus 1. X, and it's just minus 1 because that's what C is. So what we're going to do is C out a space, a minus, a space, C multiplied by minus 1. That should work. Minus 1, 0, 1, minus 1, minus 1, minus 1, and it works. We just have to remove the little space at the beginning, compress this a bit, and we got minus 1, minus 1, minus 1. Oh, I left the space, and it crashed horribly. It's minus 1, minus 1, minus 1, and we get a nicely formatted equation. Yes, this is... oh, it's negative. Let's try this with some more. Let's put it to a test. So we're going to have A is 1, B is 3, and this is 9. This is a classic case of x plus 3 everything squared. So we're going to say what it says. It says x plus 3 everything squared. We're going to have 4, 5, 9. I'm not sure if this works. The variables are incorrect. Of course they were incorrect. Let's see. What if B is very big? Like this, and 4. And yes, that it is. It's x0 plus. Something went wrong. And why is there a y in here? I think... oh, I know why. Let's fix this. Double. Also, the roots need to be double. And we forgot this. Good. Perfect. Now, let's see. 2, 104. Yes, it is. There we go. We fixed it. Why is there a Y there? Oh. I typed it. My god. Now I look like a moron. Either way, so this is the code. I'm going to format it using A style because it looks better. I'm going to put it down in the description below as a gist, so you can check it out for yourself if you want it. And if any of you want to try it out without compiling it, I'm going to quickly include Canio. If any of you want to try it home without having to, you know, having C++ installed, press any key to continue. Good, and we're going to add a getch. And this is our program, ladies and gentlemen. I hope you enjoyed this video. Be sure to leave a like if you did, share with your friends if any of them like C++ or you want them to see this, and subscribe so you don't miss any future videos. See you in the next one.